Hello, my name is EmilioFerrer. I'm a professor in the quantitative area in the Department of Psychology at the University of California, Davis, and I'm going to be telling you a little bit about some research that I've been doing with affect, emotional experiences in couples. The first thing that we have is when we collect data, we have a massive amount of data points, and it's very hard to make sense out of it. For example, in this slide, we have multiple dyads, multiple couples reporting daily experiences of the affect for up to 95 days. And as you can see, it is really hard to capture any apparent pattern in the data. One thing that we can do is look at the same graphs, the same affect, the same data for each dyad. For example, here we have data for two dyads that we're going to call 501, 502. At the top, on the upper left corner, we have positive affect. Upper right corner, we have positive affect for two individual couples. And then at the bottom, we have negative affect. And we now can see some apparent patterns. For example, we can see that there's some level of synchronicity or coherence or going up and down together for the two individuals in the couple. Here we have data for two other couples that we're going to call 523 and 540. The graphs are still in the same metric, but now we can see a much larger degree in the fluctuations. But also we can see that there's a very high degree of synchronicity in those ups and downs, perhaps more for positive affect at the top and than for negative affect at the bottom. What we wanted to do with this data, what we wanted to capture is there any clear pattern that can emerge from the data so we can say something at the population level, meaning extracting information from each of the couples that can carry to the entire sample. One way we wanted to pursue this was, well, if you could plot the data in this affective grid, for instance, here we have in the x-axis, we have positive affect going from the left to the right, and in the y-axis, we have negative affect going from the top to the bottom. So if you are in the upper right quadrant, this is an area that represents healthy affect, high positive, low positive. But if you're on the lower left corner, this is an area of more high negative affect and low positive affect. So in this graph now we have two dots, one in blue representing a male and one in red representing the female. The dot represents the concurrent affect. What is your report today? And the tail represents where's the affect was yesterday. So we have a little bit of a dynamic information here. And what we wanted to know is if we can think of these as movements that take place every day, what type of information can we extract for each individual and for the couple together? So what we did is we plotted these dynamic movements and we call them dynamic transitions or affective transitions. So I'm going to show you one movie that represents one couple. So here again, the blue represents the male, the red represents the female in the couple, the dot represents that affect on any given day, and the tail is the affect yesterday. And what we're seeing is that they're traveling sometimes together, sometimes separately, sometimes there's a lag of one day. Sometimes the affect stays in the upper right corner. Sometimes there's a transition that crosses the axis and goes all the way to the lower to the lower left corner. So we wanted to know how can we capture these patterns? How can we quantify these patterns? One thing that we did is we thought about two aspects to quantify these transitions, these movements. And these two aspects are what we call two parameters. One is going to represent the amount of movement, the other one is going to represent the amount of time. So we decided if on any given day a person's affect doesn't move more than 1 unit in a 5-unit metric of our scale, and if that happens for at least 3 days in a row, we are going to call this a period of relative stability. So in our case, our two parameters are the dispersion, more than 1 unit, and the duration or span, more than 3 days. So we did this for each couple, so we created a movie for each of the couples in our data, and then we quantified these patterns for each couple. And then we put them in a plot that we call poker chip plots. So here we have representations of these periods for two couples, on the left and on the right. And if you look at the left, you see that these two individuals show very stable patterns in the affect. They are in areas of high positive affect in the x-axis, low negative affect on the y-axis, and the z-axis, the vertical axis, represents the days. So we see that they are very, very aligned with each other in areas of positive affect. The couple on the right shows somewhat a similar pattern, but the overlap between the two individuals is a little bit not as close. And we now have two new couples, and particularly the one on the right side shows a very clear disagreement or lack of synchrony between the two individuals, whereas the male shows a lot of stability in areas of positive affect. The female affect is all over the place. Some days she is stable with regard to positive affect, but a lot of days she's stable with regard to negative affect. We wanted to now pursue this further and trying to investigate, once that we've been able to make sense of this data and extract some patterns that pertain to the individual and the couple, can we use this to make predictions about the future of the couple? But that will be for some other time. Thank you.
Low to high and low to high. Why isn't it?
Why is not high to
zero
low?
on the bottom?
to make this a little bit easier to understand.
Okay.
Numerically, it doesn't really matter how you compute, but we thought that it visually would be more intuitive to have high positive affect and low negative, high positive affect and low negative affect on the upper right, and low positive and high negative on the upper, lower left.
And so, and this is an interesting thing where even though it's a numerical scale and numbers have meanings, and 3 is more than 2, there is some arbitrariness, some amount of decision that's up to the researcher.
Correct, but that was only for the visualization. That was only with regard to the presentation of the results. In fact, for the analysis, we kept the order of the axis as you would. So the origin of the axis would be low, right? So it would be the same for the x. For the y would be reverse. You would have high at the top and low at the bottom. But the representation of that, the visual representation of that is not as intuitive as this one.